Hi everyone, we are representatives from ETF Eco.
Yes.
I'm Wilhelmina, the Vice President of Sound. This is Hayley, Director of Project Management, Esmo, the Director of Engineering, and George, who's Director of Field Services. At ETF Eco, we design, engineer, fabricate and install ETFE as pillars allow stress-free membranes. Ethylene tetrafluoroethylene was pioneered by DuPont more than 40 years prior to its architectural debut in Europe in the early 1980s. The material is extruded from a resin into highly transparent, strong and lightweight sheets, commonly called felt. Its surface is non-porous and has a low coefficient of friction, which allows the material to resist atmospheric pollution and the buildup of pollutants, dust and dirt particles. The material is unaffected by UV light and doesn't break down, discolor or weaken structurally over time. The pneumatic system has an extreme advantage utilizing the air that stabilizes the foil as an insulator. The addition of layers of foils will increase the thermal performance without increasing the volume of air within the system. ETFE foil is extremely strong, and systems integrating ETFE can be engineered to meet any specific load criteria by modifying the foil thickness or panel size. In our opinion, it is sustainable, but its most sustainable attribute is the system's ability to become a catalyst for holistic, sustainable design, driving building performance and creating facilities that are environmentally significant and conscious.
Our company and our sister company Novum get involved with the project at the early design phase so that we can prioritise the needs of the client and work alongside the architect and construction manager. We fabricate many of the structures in our own facilities, providing excellent control over quality and project schedules. We also offer warranty support and optional maintenance agreements, and we follow up with surveys for our clients to find out what they felt about the service we provided. We manufacture two membrane systems using ETFE. They are the AFP and the SSM systems. AFP is air-filled pillows, which is basically many layers combined, stretched over, and it creates like a pillow effect, as seen in like the Eden project. SSM is stress skin membrane, which is where ETFE is just pulled along and stretched across a facade or roof structure, and it creates a glazed effect, so it's basically just like glass. You see that in the Crewe railway station. We're also able to print on ETFE. This process is known as fritting. We offer this to businesses so that they can have their names and logos printed on the building, and we can add LED lights to the building depending what the client wants and needs. ETFE was originally developed by DuPont in the early 80s for use as an insulation material in the aerospace industry, making it a well-used and experienced product. ETFE is unlike any other plastic, and it has great applications for architecture and building. Another use of ETFE is for the covering of electrical and fibre optic wiring used in high stress, low fume toxicity and high reliability situations. Because of its high levels of mechanical toughness, we have been able to provide this material for cables which can handle the wear and tear of everyday life, as well as in aircraft and spacecrafts.
A single layer ETFE construction is limited to, in the dimensions that can be usually realised only with rope support. For this reason, horizontal structures are to be avoided. Two and multi-layered ETFE foil constructions are designed as cushions, which stabilize the ETFE foil layers. The frame membrane can be made up to 4 meters wide. The maximum span between centers is 2 to 5 meters. The length of the frame membrane may be available via 10 meters long. Stabilization cables available via the upper layer must be provided in each case. Due to it is the most commonly used membrane in the field of pneumatic roof structures. Standard film thickness can vary between 200 and 350 micron. It allows a safe transfer of UV rays to promote photosynthesis in plants and thus promoting plant growth. ETFE is a very flexible material and is able to cope with large deformations beyond its elastic range prior to breakage. Elongations of 200 to 300% are possible before breakage. The structural action of foil cushions is reliant on them being pre-stressed to accommodate to the live load. In a multi-layered cushion, the outlayer is the most highly stressed, and therefore it is normally the thickest, typically 200 microns. Internal layers of foil are not required to carry loads and thus are not stressed at all and can be made from very thin material less than 50 microns. The main advantages of ETFE are it's only 350 grams per meter squared, making it super light. It's an excellent light transmittance, better than glass, and it's got super durability and self-cleaning properties.
It's really eco-friendly material. The way it's built, the raw material causes minimal damage to the ozone layer. It's also the case for the materials used in the manufacturing process. There's no solvents used in the transformation from TFE to ETFE. The whole process is water-based. ETFE can be recycled easily. The aluminium frame is like to build it. It requires a really high level of energy, but the frame itself is recyclable. The transportation of the material is really easy because it comes in really thin sheets, and it's really lightweight, and you roll it up and you can easily transport it. So that's a plus. It's cheap and easy to transport. It's a self-cleaning material. It's really smooth, so the dirt just washes away with water. And if you do need to clean the facade, it comes every 5 years. 5 years, and the cleaning is it's a neutral detergent, so it's a low impact on the environment. It's simple to install. ETFE foil cushions can be installed for half the price of conventional high-performance glass roof. It weighs 1% of the glass, and it's a really cheap. Well, it's not cheap, but it's compared to glass, it has a lot of advantages over glass.
Thank you for answering those questions.
Thank you. Can I just pick up this last point? You said 1% of glass, meaning 1% of what? The cost of
The weight of the glass.
1% of the weight of
It weighs 1% of glass.
weighs 1% of the weight of glass. Right. There's lots of technical stuff, but nothing that's very clear about what it is, or rather than images of what have you got there? Images of how it's connected. Oh, what's this? Oh, I see. Samples, right. So this is actually the material here.
Yeah, and this is also a sample of it being used as like pipework as well. So you can thicken it up, like that's it whenever you thicken it.
So it's actually quite
Oh,
strong.
right,
Yeah.
the whole thing. I thought it was a little cells in. Right, thank you.
So the thicker it gets, the denser it gets.
Yeah.
So for the air pillow ones, then they're used at Eden Centre. Where else would you use them? If it's not, is it mainly for the cultivation of plants? Did you say?
Well, they've used them in the Heathrow terminal as well.
Sorry.
Heathrow.
Heathrow.
Yeah.
The Alliance Arena, the Bayern Munich stadium, is filled with it, and that's got LED lights, which the whole building can change colour and fades away.
What's its use at Heathrow?
I'm not 100% sure because we didn't work on that project. It was another company, but I know it was used there.
Just wondered why.
I think it was
Most
just for
likely
like.
the roof, because that's the main application for the pillars on the roof.
I don't really understand what the big advantage of it. I can see if it lets through particular light that's good for growing things, but
Yeah, it lets out more light than glass. Lets through a lot more light than glass. It's more sustainable than glass. Lighter than glass. Also, glass with live loads, it's very brittle, whereas the ETFE very very good at sustaining damage without breaking.
And the other stuff, the sheet stuff, what would be the main application of that?
A few schools in England have so far used it over, like just as like covering in like a communal kind of area, like courtyards in their schools. They've just used it as like a roof covering there instead of having like a pillow effect. It's just
Oh, right.
It's just a stretch over one layer.
yeah.
It's
I
not.
thought you said it wasn't suitable for flats. Was it?
know
That's
that-
only the pillows. This is like the SSM system, so it's just stressed skin membrane. So that's just whenever it's stretched and fall over.
Because it can stretch over 200 to 300% of its original form, so it can stretch over a long distance and retain its structural integrity.
Right, I thought you said it wasn't suitable for that application. Without
No, it's horizontally it's not suitable. It's not as strong horizontally with the windows and such, but vertically it's very good. Yeah.
Just, the Summerland fire. There was a very famous fire, can't remember the exact date, when, although it didn't catch fire, what happened was this melted and dropped.
It should dissolve, so it shouldn't just disappear because
Shouldn't just, let's try
it
and
shouldn't
do
just
that.
like it shouldn't create droplets.
Sorry,
It doesn't create droplets of
it
plastic.
doesn't? Have you tried?
Not yet. We don't actively just burn.
We try to see if it creates the droplets. I'm sure that would drop. Or, if it, again, if the building is on fire and this, the roof, it's going to be very toxic, isn't it?
Yeah. Would be.
Just, having lived through the era of Summerland and one or two other very infamous fires, where people have died not through flames but through smoke insulation, or the causes of it